Good morning, everybody. Today, I'm opening the track around DevOps and continuous integration, and specifically, I want to talk about monitoring and metrics from a development point of view, which is something quite uncommon because monitoring and metrics usually live inside the operation and production world. So a bit of my background. I currently work for Atlassian for their on-demand system, where we put every Jira, whatever product we have, in a software-as-a-service model. So I'm working on that. I do some consultancy for Qatar, which is kind of Gartner, but as a smaller scale. I wrote a chapter on monitoring in the web operations. Do the DevOps days, worked on Vagrant and Vivi, for those who know that, and I'm working on the DevOps cookbook to kind of gather all possible things that people are trying to do with DevOps in a book. So that's a bit what I'm trying to do during my day and my night and whatever time I have left. But today we're here because I'm assuming you guys are pretty much in the development mode and you care about your code. And the other assumption I make is that you're all like these super specialists, certified. You read everything and you're doing everything by the book and even better. So, yeah. So your code, you are familiar with doing TDD, test-driven development. That's one of the things they learn you that's important when you start coding. So yeah, your baby is in that little test environment where you do that tests, really controlled environment, and you monitor that very hard to see if anything fails. And sometimes things get a bit like dirty, like in your test environment. It's not the same as on your laptop, but still it's controlled, you wipe it off, it's clean, and you fix it. The other thing you learned is that your code only gets value if it's running in production. So for who is that the first time he hears that? Nobody. Great. So this is obviously where the whole continuous delivery and going to production clash has escalated, or lately has improved the collaboration. So pushing things into production requires a collaboration between the dev and the ops people to make that work. But you know that baby, you foresee every possible thing that can happen and you put them like in the weirdest ways to protect against the environment they're getting in and your code is running in. But in production, things fail, and sometimes they fail quite hard. So even if you did like everything by the book, and you code it, and you deploy it, damn, my code blows up in production. So do you care as a developer that that happens? I see some people nodding. Some people would shrug, maybe. I don't know. I hope not. At least I assume you care. And you care beyond it being tested and built. You care about it running. So the reason why some things fail in production is because you're having that idea of all the things you want to do and you make fantastic code. But the code that's in production is probably not the code you dreamt of. So Disney, I don't know if you are familiar with that, but within his company, he tagged people into 3 states. There were the dreamer states people, like, the sky is the limit. We can think about every possible new thing in our Disney studios. And then there were like the critics who've done it all, seen it all, fail, success, whatever. And he made sure that a dreamer never entered the same room with a critic without a realist. Because the critic would kill the ideas of the dreamer. And the dreamer would have a hard time convincing the critic of something new. So he understood, like, and this is real, that you couldn't do something without the realist. And this is what we're pragmatic people, we're trying to do. We're trying to align those two states. And we're not like in the dream state, like push whatever we could think of out. No, it's running things, that's where you learn. So lately I've started with all those stories I was seeing about DevOps, of categorizing the things people had been doing in 4 areas. There is the area which is extend delivery to production. Continuous delivery, deployment, all that stuff you're probably already familiar with as a developer. Push faster to production. Get more number of deploys a day, per hour, per minute, it doesn't matter, like push out. But as a reaction, the ops guys have said, like, you can push whatever out, but you got to learn. You got to learn when you push out, because otherwise you're just going to push faster crap out that doesn't run in production. So the area 2 is about whatever ops knows about running or the stuff in production to feed that back into production, to the project. So who has the first area covered, more or less? Raise your hand. A few people. Who has the area 2 covered? No hands? Really? Interesting. Area 3 takes area 1 even a step further, is that you embed the project people directly into production, to the operations team. So developers start wearing pagers, all that stuff. You feel the pain of what's actually in operations. And the reason is not that much that the ops guys want you to feel the same pain. It's that you can learn what's important once your application is running in production. Because if you don't know that, how can you anticipate in your dream state what you need to cover? So it's getting that feeling while being in production, while being in operations, that you learn. And once you're successfully running or not successfully running, it's not enough to just say, let's put up some metrics and some faults or some error pages or whatever. We need to get better in our project as well. So area 4 would be an example of having your sysadmins join your stand-ups to prioritize your backlog. They're directly feedback into your project. So it's not about like just sharing some stuff. They're co-responsible for your project. They're aligning with the priorities that your backlog is going. They have to listen in. Maybe there's a feature more important than your backup could be. They would know if they stay within their own area. But this is about getting the feedback in the beginning. Almost the feedback from the end user or for what's happening in your application in production back to the business. The feedback link not a lot of people have. There's another acronym that John Willis came up. It kind of sums up the same thing, like culture, automate, measure, and share. So automate is probably what DevOps in general is most known of. Like continuous deployment, infrastructure as code, every automation feature. But there's a few flip sides. The measurement and sharing, what we're going to get into today, and the metrics, is your return channel of your feedback loop. And the culture is more even not at the technical level, but at the people level that you're trying to accomplish. And by doing that, you get a sharing. Like we share the same pain, we share the same business goals, and whatever. So this kind of sums it up in a different way, and it kind of maps into the areas. So smaller, frequent changes, and faster and better feedback. Because again, going faster without breaks, you won't do that. Don't do that. So that's important. So to rephrase, Area 1, being Jez Humble, which is co-author of the Continuous Delivery book, which I can totally advise for you to read on that area. And most of you, like into continuous integration or continuous delivery, there is a kind of maturity model. So based more or less on industry levels of what people have been doing. And you notice, like, on the right, continuous deployment to prod. At the time that was written, I think that was 2008 or 2009, people would consider that insane. Nobody does that. Currently, it's becoming less insane with all the automation tools we're putting into place. Like, it's becoming faster and easier to do that. At the same time, infrastructure as code was brought into the equation, and that not only your application code could be reused and put into that model, but also your infrastructure as code. So things like Chef, Puppet, CF Engine, all reduced the installation of a server to code. So you can put that into a repository, reuse that from prod to test and dev in all the environments. Even a tool called Vagrant, which, if you don't know it, I can totally recommend it. It almost brings like the production machine virtualized on the developer's laptop. So it's using VirtualBox, but you would configure it with the Puppet or Chef code that is the same as you're running in production. Your application is the same as you would do in production. And it's coming from the same repository. It's almost that these things are like libraries. You would consider libraries in your code, and you just have a dependency. But because it's on the developer's laptop, the developers effectively deploying code every time, like you would do in production, with the same workflow, with the same tools. So that creates like the shared discussion point, like, oh, you're using that tool, but we're using the same. How do you do this? So you kind of bootstrap the collaboration also between the two worlds, which is pretty... so some would say tools are not important, but I found like people using Vagrant, for example, it puts you in a new perspective of what you can do. It gives you new opportunities, and so it changes your mind on the flexibility on how you do things in automation. So you would create that pipeline not only for your app, but also for your infrastructure as code, and you integrate that into your continuous integration. That's still on the automation side, continuous delivery, but I just want to point out that there's another layer that's already covered and heavily discussed in the DevOps automation area, which is the infrastructure as code, and doing it the same within your CI cycle. Not only spinning up a new app, but spinning up a new VM, deploying it the same over and over again, and running tests against it. Delivery feedback. Because you are using the same OS, the same settings on your development laptop, you will notice that something will fail. It's not that you're running a Tomcat on your laptop in your Mac OS. No, you're running it on Ubuntu with the same version levels, with the same packages. Everything's the same. Faster feedback in your whole cycle. Pretty important. Not at the end of the build. Okay. Today I want to talk about this point, but the reason why I briefly went over the first point is that there are some similarities between Area 1 and Area 2. So John Allspaw, I would call, is the guy leading the track with Flickr and Etsy and all the things he's doing with getting feedback from production to the project. Okay, monitoring and metrics. This is a horrible slide. As developers, you're quite used to think that the app layer is the center of the universe. I just wanted to point out that there's a lot more flying pieces around you that needs like metrics and monitoring where people are busy on. So the success of your app in the middle actually depends on a lot of the different parts of your environment your app is running in. So if you care about your app and not breaking, okay, you worry about your code, but you should worry also about where your application is running in, how it's running, in what environment. And what's interesting, if you go look at the previous slide, on the top there's the user somewhere, and lower there's hardware and network, all the things, the horrible things we want to abstract away, but they're still important. And so if you're doing monitoring from a user perspective or a business perspective, you're kind of simulating the behavior of what your users are doing to get feedback whether that functions or not. The things at the bottom, if you do monitoring of your memory or CPU, that's interesting, but it's more if the top fails, then you want to have diagnostics at the bottom to see what caused the failure. So what made it fail? It's almost like a unit test. So your CPU and testing and monitoring your CPU is just a unit test. In itself, it doesn't tell you much, but once the whole chain breaks, it gives you feedback where it broke. And is it working? That's actually BDD. You're trying to do a check across, and it gets an impact on all your lower dependencies, and it gets you good coverage, and it's a behavioral test. So why can't we go from TDD to monitoring-driven development? It's all looking so similar. Infrastructure as code, CI, BDD, unit tests. There's no real difference anymore. So why don't we just create a monitoring check before writing a feature? Because my usual test will give me some feedback. My monitoring test will be across a larger spectrum of dependencies of my app, so I'll get better feedback at that level. To be honest, I've never seen anybody do this, but it has been discussed before in a way of getting into that style. And I think the main reason why people haven't gotten into it, because the tools haven't been adjusted to that idea. It's not yet that easy, but I think it's where we are going for. So similar to a CI system, we at Atlassian, we have an availability radiator. It's not our build, it's our service. Is it up or down? And if it goes red, that's important. Same thing as your build server. Is it red? You should fix it immediately. That it goes to green. Again, similarities from both worlds. So, monitoring-driven development. With the current state of monitoring tools, I started my new job specifically to go into metrics and monitoring, and I did some research on what tooling is out there and how can we reuse it to get into that mindset of MDD. There's some links here. You can read about it later. But to me, it's more like, come on. It's like every possible solution is done 10 times over in 10 tools, and they never do it right, or only one feature right. And to me, it's like almost Wonderland. I couldn't think of a better name. So what I found out is that the traditional monitoring tools, Nagios, Itzinga, Xenos, Opsware, for those familiar, they kind of make that hard. Who has seen a screen like this before? Oh, okay. That's good. So your ops guy somewhere in a corner is looking at those red, green parts and seeing like, oh, you know what, the ping is okay, all that stuff. Ugly, isn't it? But and the same thing is happening with metrics tools. Like, two of the most currently used are Munin and CollectD. They don't do a check whether it's up or down or in a flapping state or whatever. They will gather information like how much traffic network is going in and out. So they're just collecting those on a time series based. These seem to be currently the most active of the traditional metrics systems. Ganglia, also still a traditional one, solved a specific thing in a way that the metrics with CollectD would be in reporting to a single server. And if you have a lot of servers, or in different data centers, you want to group them. And you want to have them report to one local server, which forwards it to a central server. And that gives you a scalable way of setting up your metrics. So you don't have to have one big server that gets all the metrics. So Ganglia solved that problem effectively. Still on the graph side, kind of looks ugly. But it's useful. So in general, what happened is it started out as a hashtag, monitoring sucks. It's now a GitHub project where we try to gather all the information we could think of, or the blog posts or new tools that are solving problems we have with the old traditional tools to become more flexible so we can almost go into the monitoring-driven development mode. You've seen that problem. It's a bunch of Perl script with the guy who just understood HTML, but really, we don't want that style. But considering it was written by sysadmins who are not used to developing apps, it's not too bad. But we could really use the help of developers or UI people to make that part better. No API. You have a CLI you can do some stuff with, but that's it. It's hard to control your Nagio system because it isn't meant to be open as a tool, or the CollectD or whatever. They have some internal API, but it's not supposed to be exposed to get metrics. And that's one of the problems I saw while doing the survey, is that they're creating new silos of information within each tool. Even though it wasn't already enough that we had a silo divide between dev and ops, we have a tools divide within ops, because whatever we run, and if one tool is good at one thing, we need to run that tool, but then how do we link it to that other tool that's good in that other feature? Makes it hard. Hard to scale. Those things were still in the idea of let's add a server every month. This is not what we're doing. We want to scale up, scale down, add new test systems, get them into monitoring very fast, but it was never designed for that. A lot of these tools, when doing a configuration change, you have to restart it. Seems a bit retarded, but this is the way the state of those tools is. You guys all know better in your application code, but it's really bad at that level. And I said it before, you can't imagine the ways people try to get data out of the tool by using the UI and scraping the application to get data out of it. And then, of course, the UI changes, everything breaks. It just wasn't meant for that. And maybe it was intended, maybe not. You'll have to pass by the sysadmin to have it changed. We don't want that. You might think that's job protection for sysadmins, but actually, we don't want to do that stuff. We want to say, let's click that button and get your own stuff. Then we can move on to more interesting problems. But none of these tools have kind of made it easy to do that. So the solution, like we had in the automation and the continuous delivery, oh, IT, you can't deliver us 20 servers immediately? Let's go to the cloud. Same thing happened to the monitoring metrics. So people were taking all these problems into account, and they're spinning up these cloud services that allow you to get your metrics in a sexy way. Graphs, very easily, self-servicing, delegation of whatever you want. So there is a similarity of internal boundary. The IT group is not flexible, says no, we can't do that. We go to the cloud, and now we're coming back. The internal IT monitoring systems are trying to solve those problems internally. Because for some reasons you can't go outside to do your monitoring, or you want to keep track of everything, and just sometimes it makes more sense to build it internally. So what I'm going to do now is I'm going to show off or go through a few of the what I call new concepts that are introduced in different tools that are currently on the monitoring and metrics open source tools that kind of try to solve the problems I went through earlier. So Sensu is a framework that was created by the Smithsonian. And instead of having one for loop that goes over all the servers every time, which isn't very scalable, because if your loop takes too long, then you can't go within a period, check all your servers. So it introduced a message bus, and there's one server who says, monitor this. And then there's a bunch of workers that just listen in on those messages and start doing it. So it's like a worker model, but it allows people to to scale. Like just add a few more workers instead of having to buy bigger boxes so we can do our loop faster. No, that's not what we want. So it's a scalable architecture people started doing. A side benefit of using a queue is that you can have people listen into the queue for whatever check or metric that's important to them. So sharing that information becomes a lot easier if you want to listen in to whatever is happening in production. The people of Rocksteady, with that tool, took it even further, and they took the same message queue system, and they added Esper to not wait while every metric is somewhere in a database and then do the analysis. They are doing an in-stream analysis of whatever passes through the stream. I know probably for all you guys, it's like, you know what, this is like concept we're used to in development, but within those monitoring tools, these are kind of new concepts that are introduced. But clearly, if you have a lot of metrics or a high volume flow, it helps in having them in a stream, almost real-time based flow, because you don't have to keep track and query the whole data over and over again. New concept, another new tool gets there. To give you an idea, there's a tool called Reconnoiter, and it's almost like we want to better the world of monitoring. So you see there is really a will to improve, but yeah, we're not there yet. We're still the monitoring sucks a bit less, but it still sucks. Okay. We now have all these metrics flowing in, and we have scalable systems so we can add more nodes reporting in. The next problem arises. They're all writing to the database at the same time. we're having hotspots. It's not like a read system, like scaling for multiple reads. No, it's like congestion. Right, new metrics. So another tool, again, OpenTSDB, created a tool that runs time series on top of Hadoop, which allows you to have like multiple masters where you can write to at the same time, and you can have the read clients as well, just to solve that problem. Something that wasn't solved, but came from the fact that we're gathering more metrics, getting a larger flow to handle that volume. And look and behold, now we can actually create graphs. Once we have a lot of metrics, Graphite was the first tool that actually made it self-servicing to create your own graphs. Silly. But it was so, the whole community was so relieved that we can, for the first time, create on-demand graphs, and we didn't have to think up front, like, what do we want to relate with what metric? Pretty powerful. Self-servicing. So we just gather all that data, and we give access to the developers and say, you know what, you can build your graphs. It's self-servicing. You don't have to pass through us. So that's pretty powerful. Of course, you need to have the will to look at the metrics. But that's, again, at the point like, do you care? But if you care, there's no one blocking you anymore to get at the data and to run queries or create graphs from that data. And on the app level, it's even easier. How many people have tried New Relic before? A few. In a nutshell, you add one jar file or something, an application key that acts as authentication to your application. You start your application, and it starts spitting out all the metrics about everything that's happening in your application to a website on the cloud. And you can see, this is, for example, whatever happens in your database. So how self-servicing easier can you get it? So I don't want to hear any complaints anymore that I can't get to that data. No, it's up to you. If you can't do that, sorry, nothing's going to help you beyond that point. And I take it even a step further. Remember the layers we're doing? The user on top of that. We can actually check his browser load time. So how powerful is that? You're actually almost at the user itself watching what his experience is. It's no more a simulation. It's like it's in the browser. It's reporting back through JavaScript. It's logging, and he gets all that metrics. So it's almost like the beginning till the top to the bottom of the stack. And what's cool? You can create these kind of dependency graphs with app dynamics. Whenever a user queries or e-commerce site, he's going to do an order over a message queue, and that happens to that database. And I can see the delays in timings that's actually happened on all of these layers. I think that's pretty powerful. So for me, it was like, I want this. So it's amazing. Just by exposing the metrics and feeding them, what you can learn from them. If you're into Java, there's GMX trans, kind of feeds directly from GMX into Graphite, for example. So this is just informational. I've talked about just hooking up New Relic as a library or whatever, and it gives you information, which is kind of interesting, but you're still needing to go out to the cloud to get all those metrics. Sometimes that's not allowed. So the people at Etsy, they created a simple daemon called statsd, and your application would feed it through UDP with these values like response authentication time 1, view get milliseconds. So it just pushes out that metrics from your application with a very simple API, almost like an S3 bucket, like you put things in. And your statsd is going to do the counting. So if you do a response all 200 multiple times, it's going to keep track of the count, number of times it received that call. And then it will feed that into the metric system. It's a simple system, but it's proven very powerful as a way for exposing whenever you need something tracked in your code. Instead of coding your own metrics tracking thing there, you just push out that information to something that reuses the toolset of the admins for monitoring and metrics. Same is happening with metrics library. Codahale started with it to kind of make that easier in your code. So if you're into Java, it's almost like instrumenting your code with metrics and monitoring you can use. There's more. Why not relate it to Google Analytics? They're currently at Google, but why not export them back into your monitoring system? So you can relate that to your application metrics, to your system metrics, to your network metrics, and so on. Or other cool stuff. I put in a new version of my application, and I'm measuring whether it has an impact on memory or CPU or performance or some things like that. So you tag your metrics so you can see whether one of the things, for example, they found out is that the delay it takes to render a page is just correlated to the number of clicks you're going to get because people won't revisit your site. So things like that, you can track whether a new version has an impact on several of these things. So relating that, all those metrics, all those sources of information that are typically scattered around gives you a very powerful information source. Like, do you really need to push out this version? Or what actually happens if we push out this version? And then there's a category that's not that well known. It's called meta-ops. So you're trying to push and gather all these metrics, but you want to know the context while you have captured those metrics. Like on a graph, you will see CPU usage go up or something happening. But you want to relate that to a change that was introduced. So if you would correlate on the graph, like version X was introduced, like a meta-op, new deployment was done, or new version of the app was live, or we introduced an incident, or whatever, those are meta-ops. And you can put them on your graphs for information, and that gives you new insights, some things you wouldn't correlate before. And then there's logs. Logs, I think, I haven't put it up here, but if you would have like a regular expression to match log lines for example, the only standardized syslog, it's an expression of 2 pages long. It's standard, but never standard. For some reason, that's one of those things that gets reinvented over and over again, like the format. Even though you have log4j, it's like whatever you put in that line, it's going to have a different structure. It needs to be parsed. So, but how do you relate that back to metrics? Simple example. A web application server, Apache, spits out the error codes, 200, 300, 500, all that stuff. And you want to have a count of how many errors of pages happened. So Logstash follows the Unix pipe analogy. So it takes an input of a syslog, it could be Twitter for that matter, it could be a Redis database, a file, and it puts into a filter and then outputs it. So one of the outputs you will see is Ganglia, Graphite, Nagios, all those systems. So whatever happens in your logs, you can relate that back through that system to your metrics. Count the number of errors, or in our case, the number of out-of-memory errors in Java we're getting all the time in a certain app. These are the things we want to track with that system. It makes it very powerful. So we talked about the continuous integration. And we actually want to put the tools of the monitoring metrics across DevOps, because we want to push them back to those levels. And if you are starting to reuse the same tools for the monitoring and metrics at the different environments, you, again, like infrastructure as code, you're working on the same stuff with the same tools, but maybe for a different reason. So in production, it would be like postmortems. But in development, it might be debugging. And if you're reusing the same tools, that's going to be much easier to talk with the ops guys during a production problem, because you're already used to watching the graphs, know what it's capable of. So that gets you into a new state, metrics-driven engineering, like whatever we push out, like put those metrics out. It's almost like a belief, like TDD or monitoring-driven development, or here at Etsy, the church of graphs. So whatever we want to graph, that's important, if you make that visible. So to sum up, I think the metrics are there, but they're not evenly distributed yet. And I encourage you to talk to your ops team of putting some way of exposing those data, and then for you is actually working with that data and looking at that data to learn from it. Because you can deploy 100 times, but if you're doing it wrong, you can't learn without looking at the logs or the metrics. These are a few things like the monitoring operations book. Visualizing obviously is important. It's almost getting you into statistics mode, like what happened here, what should we do there. The queuing, because of the distribution, more and more tools starting to adapt that queuing system. Puppet or Chef, it doesn't matter, or data analysis you're starting to do, like you can predict things to happen on that level. And I guess that was me. Hope you are eager to try it out and have fun with it. Okay.